The question we are solving now belongs to test series 2. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the question, there is a RL circuit given as shown in the figure. It contains two inductors and two resistors. The two inductors have inductances of 2 Henry and 3 Henry, and the resistors have resistances of 1 ohm and 2 ohm. The current through the 2 Henry inductor is given as I1 of t, and the current through the 2 ohm resistor is given as I2 of t. It's given that I1 of 0 is equal to I2 of 0 is equal to 11 ampere. We need to find I1 of t at t is equal to 1 second. Please note that the current question is a common data question. So from the given circuit we see that the given circuit can be viewed as two meshes, and each of the meshes carry a current of I1 of t and I2 of t. So upon applying mesh analysis to both the meshes, we see that the mesh equation corresponding to the first mesh can be written as 2 di1 by dt plus 3 times d by dt of I1 minus I2 plus I1 of t is equal to 0. Please note that the current through the 3 Henry inductor is I1 minus I2. This upon simplification becomes 5 di1 by dt minus 3 di2 by dt plus I1 is equal to 0. Upon taking Laplace transform on both sides of this equation, we see that the equation gets simplified as 5 times Laplace transform of di1 by dt, that is s into I1s minus I10 minus 3 times s into I2s minus I20 plus I1 of s is equal to 0. But we know that I1 of 0 is equal to 11 ampere and I2 of 0 is equal to 11 ampere. So upon substituting this for the same and simplifying the equation, we see that the equation can be simplified as 5s I1s minus 3s I2s plus I1s is equal to 22. This is because I1 of 0 is 11 and I2 of 0 is 11. Let us mark this as equation 1. Similarly, upon applying the mesh analysis to the mesh 2, we see that the mesh equation can be written as 2 times I2 of t plus 3 times d by dt of I2 minus I1 is equal to 0. This is because of the reason that the current through the 3 Henry inductor is I2 minus I1. So this gets simplified as 2I2 plus 3 di2 by dt minus 3 di1 by dt. Sorry, these should be small i's. This is equal to 0. Upon applying the Laplace transform on both sides of this equation, this gets simplified as 2 plus 2I2s plus 3 times s into I2s minus I2 of 0 minus 3 times s into I1s minus I1 of 0 is equal to 0. Here we see that as the terms corresponding to I2 of 0 and I1 of 0 get cancelled. Hence, I2 of s can be written as 3s divided by 3s plus 2 multiplied by I1 of s. Now this is equation 2. So now by using the equations 1 and 2, we can simplify for I1 of s to get I1 of s is equal to 11 into s plus 2 by 3 divided by s plus 1 by 6 multiplied by s plus 2. This can further be simplified as 3 by s plus 1 by 6 plus 8 by s plus 2. This is by splitting the I1 of s into partial fractions. Now by taking the inverse Laplace transform on LHS side and RHS side, we see that I1 of t can be written as 3 times e power minus t by 6 u of t plus 8 times e power minus 2t u of t. This is because of the reason that L inverse of 1 by s plus a is equal to e power minus at u of t. So from this we see that I1 of 1 second is equal to 3 times e power minus 1 by 6 plus 8 times e power minus 2, which upon simplification can be obtained as 3.62 ampere. Hence the correct option representing I1 of t at t is equal to 1 second is D.